Hello everyone, it's my honor to share our work with you. Our work's topic is CoArgue, fostering Lurkers' contribution to collective arguments in community-based QA platforms. Collective arguments refer to the aggregation of argument-related elements from online discussion on specific topics. For example, discussion under non-factoid question threads like "Should I invest in Bitcoin or would you get into a self-driving car?" Estimated question threads involving collective arguments account for over half of the user-generated content contributed by CQA users. In addition, for the contribution to collective arguments, content generated by individual users can be limited, and CQA platforms need to maintain a relatively large contributor base to ensure the sustainable development of collective arguments. From another perspective, contributing to collective arguments can also sharpen the user's writing skills and potentially meet their self-fulfillment if their writings receive acknowledgement. However, most CQA users are lurkers who frequently visit CQA sites but rarely publish any content. Therefore, for the development of CQA platforms will need to sufficiently boost the motivation and ability of lurkers to turn them into active contributors. Otherwise, the thriving development of CQA communities could not be guaranteed and might even shrink without sufficient contributors. In this paper, we plan to solve the problem by our designed system CoArgue, to foster lurkers to contribute to collective arguments on CQA platforms. We started with a formative study. We recruited 11 participants self-reported to be lurkers of CQA platforms. We asked them about why they were so silent on those platforms, what the major factors are preventing them from writing responses, and what kind of technical support could make them more active contributors to the collective arguments. As shown in the table, we summarized the obstacles faced by lurkers into the motivation and ability categories, with subcategories confidence, willingness, digesting, and writing, including specific obstacles like consider the contribution from oneself is trivial, feel overwhelmed by too many arguments, and suppose the angle to contribute is hard to locate. With those findings, we further derived design goals for our CoArgue system. With the CoArgue system, we aim to first, encourage users to participate in collective arguments and communicate the inherent value of their contributions. Second, use technology to support an engaging and efficient interaction experience with the collective argument. Third, present a holistic view of the collective argument and facilitate the digestion process. And fourth, help locate what to contribute based on the existing content of collective arguments. Eventually, we designed the CoArgue system with two components, the collective argument processing pipeline and the user interface on top. We trained a BART model based on the ChangeMyView dataset to automatically extract the claims and premises from the collective arguments. After that, we performed sentiment analysis on the claims to analyze the stance of each claim in terms of positive, neutral, and negative. Furthermore, we clustered the claims in each stance group for more structured digestion. For the premises, we collected all the associated premises that supported claims within each claim center. Then we concatenated these premises into one paragraph for each claim center and consequently fed them into the pre-trained keyword model to generate keywords. The keywords were put into further use to assist users' argument writing in later parts. The user interface of CoArgue resembles the interface of Quora, with a similar answer view on the left. With the help of stance analysis, the claims were marked in blue, gray, and red, representing positive, neutral, and negative, respectively. The premises in an answer post were marked in green and were interactable. Whenever a user clicks on a premise, the chatbot tutor would point out the claim center it supports and list those answers containing premises supporting the same claim center. The navigation view listed the claim centers in each stance group and illustrated the overall stance distribution. Each claim center was encoded with its popularity defined as the number of claims it contained to total. Upon clicking, users could explore all the associated claims, and they may further click the claim and jump to the original answer post in the answer view. The chatbot tutor will discuss with the users to assist their argument writing by guiding users through the claim centers. After pinpointing a specific claim, user can opt to discuss with or get hints from the chatbot, with the hints keywords powered by previous premise keywords extraction. The writing interface contains the template generated based on the conversation history between the user and the chatbot. And after user finished writing, there would be a contribution view showing the user's writing statistics, including word length, stance, and their contributions to the stance group. In comparison, the baseline system removes all additional features and replaces the right side with the related question list, which is similar to Quora. To evaluate CoArgue, we conducted a within-subject study with 24 CQA lurkers. The participants were asked to interact with two sets of collective arguments about investment in Bitcoin and self-driving cars, each from a selected Quora thread. Participants would use the CoArgue system and the baseline system on one set of collective arguments. The order of the two sets and the two systems were counterbalanced. Then we invited participants to an interview and to complete a questionnaire. Both methods concern their ratings and comments on system usefulness, visual designs and interactions, and system usability. The evaluation results showed that CoArgue is more effective in supporting lurkers' motivation, ability, and improving their engagement during the contribution process. Also, with CoArgue, users get more confident and have higher self-perceived quality of their writings. For more details about the results and user feedbacks of CoArgue, please refer to our full paper. In conclusion, we proposed an NLP pipeline for processing collective arguments and built CoArgue based on it, a tool for fostering lurkers to contribute to collective arguments on CQA platforms. Finally, the user study shows the users' attitudes towards our CoArgue system. However, this proof of concept system also has limitations. In the future, we plan to evaluate CoArgue with more diverse user groups, explore the efficacy of CoArgue on less popular topics, and monitor the long-term effect of CoArgue on reducing CQA users' lurking behaviors. That's all of our presentation. Thank you for your listening.